Please join me in welcoming David Mimno for a talk entitled The Library as a Dataset, Text Mining at Million Book Scale. Welcome.
Thank you for the introduction. As you heard, I'm a computer scientist. So you might be wondering, why am I on the Digital Humanities Initiative Committee at Princeton? What do I bring there? My expertise is in algorithms and scalable inference for large-scale probabilistic models. And I think that the answer to that, what I hope I can contribute, is the methodologies that humanists can use to make use of the enormous amount of digital resources and the advances in probabilistic inference that have occurred over the last 10 years. So just to give you an outline of where I'm going here, I'm going to start by talking a bit about the digital humanities, very briefly. And then I'm going to go into a particular method that I've got experience in, which is statistical topic modeling. Have people heard of this before? Some of you? Okay. And then I'm going to go through a case study on 19th century novels where I and my colleague Matt Jockers at the University of Nebraska were able to apply this statistical method to particular questions that he has as a scholar of English literature. I'm going to talk a bit about digital humanities first. And I would say that the way that I really think of the role of digital humanities is not, as Greg said, or I agree with Greg, not to create a new discipline, but to make computing as vital in humanities and social sciences as it is in engineering and science. And the way I kind of visualize that is, in every university I've been to, there's always this sort of imaginary boundary. At Princeton, it's Washington Road, that sort of diagonal street. If you're east of Washington Road, then computing means simulating the plasma in a fusion reactor, or modeling the global climate, or looking at the entire human genome. If you're west of Washington Road, computing means Microsoft Word. And if there's anything that I feel that I want to contribute over my career, it's to change that, to make computing as vital west of Washington Road as it is east. So what is the digital humanities? And this is kind of the picture that I want people to avoid. It's that you take some humanities and you scan it and you get digital humanities. And you can think of this as two sort of phases. And the first phase in digital humanities is exactly that digitization phase. And there's an enormous number of very important and very, very impactful questions that you have to answer when you're digitizing. I mean, it really matters getting this right. But what's important, and what the real impact of this type of technology is on the right, this what I call phase two. Other people break this into three waves. This is the way I think of it. That digital technology should be part of a methodology for humanistic inquiry, for social science inquiry. So if you look through the Yale course catalog, there's probably a lot of classes that are something like research methods for biology or research methods for sociology. A lot of fields have particular ways of making measurements and understanding the meaning of those measurements. And I've asked humanists, like, do you have the equivalent of this? And there really isn't one. There is no research methods for English. And one of the possibilities of incorporating digital technologies as an organic part of a discipline, not as a separate thing, is to have a suite of research methods, ways of making measurements and thinking about the meaning of those measurements that can make the difference between using technologies as a sort of thing and using technology as an assumption. It's just something that you do at some point in the process that you work in. So I want to talk a bit about this particular statistical model that I work with, statistical topic modeling. And I want to describe the reason that a lot of humanists and people outside the sort of traditional people who are interested in statistics, the reason they've been interested in this is that it addresses a couple problems that really get to the core interest of humanists. Now, as I said, I'm a computer scientist, so I'm always on thin ice when I talk about the real interests of humanists. But something that's had a lot of resonance with people that I've talked to is that humanists want to take a big body of historical material and look at it and say, what happened? And there's two real big problems that people are always facing. First, there's too much stuff. You cannot possibly read everything that there is. You cannot process it. You cannot use the methods that people have been using. It's just too big, and it's only getting bigger. The second is that there's an incredibly hard process of getting away from the biases, from the preconceptions, or from the stories that have built up about the past. You know, as Daniel Kahneman says, that the world makes much less sense than you think it does. Our brain is this amazing engine for taking noisy, crazy data and making it a coherent story. And one of the hardest things that humanists face is trying to get back to the real, messy facts of what really happened and away from these clean stories. And so a lot of people were very excited to see this. Do people recognize this tool? This is the Google Ngrams viewer. It's a collaboration between Google and some folks at Harvard. And what you can do is put in a word or a phrase. This is just their stock example. And you get back wiggly lines that show you the frequency of that word or phrase in several million books from the period where the statistics are kind of accurate is about 1800 to the present day. And so a lot of people said, this is what we've been looking for. First of all, it looks at everything. This is millions of books. We're not making decisions about what we can read. Second, it is in some way objective, or as objective as possible, because it's just counting things. But there's a couple problems. The first one is that even though this is theoretically based on everything, you're still looking through this tiny keyhole of a single word or a single phrase. And you have to come up with that phrase yourself. There might be 10, 100, 1,000 other words that are interesting to your research question, but if you don't know about them, you're not going to find them. The second problem is a little more subtle, and I like to give this example of my colleague at Princeton in the Digital Humanities Initiative, Meredith Martin. She was writing this book about the rise and fall of meter. Meredith asked me to mention that this book is on the shelves. I can give you the Amazon link if you'd like. And as you can see, Meredith is very much in this tradition of taking something that we think we know and showing that we really don't know that much about it, that there's a lot more complexity. Things were happening in overlapping periods. And she's trying to get away from the pat narratives that we've been handed down. And so she was really interested in these word search methods when they came out. And so she did a search on several words and found that there was an unusual spike in the words syntax and prosody in 1823. And she thought, some event or some cultural trigger has led to a spirited debate about meter or poetics in 1823. So we need to find out more about this. Turns out syntax and prosody were the name of two famous racehorses. And as you can see, prosody won very easy. They were really fast horses, and people were writing about them all the time in 1823. So this is both incredibly depressing and also very encouraging, because it's depressing because this should be the best case. Syntax, prosody, these are about the most specific, concrete, single meaning words that you're going to get. These are highly technical vocabulary. And even in this case, we can't get away from the racehorse problem. But it's encouraging because if anyone who speaks even a modicum of English looks at this page, there is no question that this is about poetry or meter or syntax or linguistics. This is definitely about racehorses. So the intuition that we get, and I think the reason that a lot of people are interested in the type of method that I work with, is that context is vital to meaning. And it is not enough to simply search for the string prosody occurring in books. We need to look at prosody within particular contexts. So let's get back to the type of method that I work with in text mining. Let's say we have these three documents. They're sort of news stories. You could classify these. Maybe you have labels already. Maybe you could put them on and say that the one on the left is probably about sports, and the one on the right is probably, you could call it business, and the one on the bottom maybe organized labor. But then the question becomes, how many categories do you apply? So this document here, Cablevision signs deal to carry NFL Network. Is that sports or is it business? Well, it's kind of both. So I guess I should really just create a new category, business of sports. And then what if I get, okay, talks between NFL referees stall, that's kind of sports labor. Okay, I add one more category. Okay, GM plants hit by UAW strike. Ooh, okay, that's another category. I mean, it goes on and on. You can kind of see how I've set this up, that there's really not a single category for each document. It can be better represented, not best represented, but better represented as combinations of three simpler categories, three themes: sports, business, and labor. And one way to think of this is that we're not applying labels to documents as a whole, we're applying labels to words. And so I can go in using my domain knowledge and color each of the words in these documents by their theme. And I could say that maybe, okay, in the top right, General Motors earnings fall, that's kind of 100% business. And the one on the bottom right, GM plants hit by UAW strike, that I can count the words that I've assigned to the different themes and say that it's about 40% the blue theme and 60% the green theme. And to get back to the idea of contextual disambiguation, let's say I say that document on the top left is pretty much 100% about sports. And there's a word somewhere in the middle that is field. So is this a playing field or a magnetic field or some other type of field? Well, I don't really have full natural language understanding. That's 100 years out in AI research. But I can decide whether I want to put that word field with the sports theme or with the magnetism and physics theme. And I can get clues about what choice I should make by looking at the other words in that document. So if most of the words in that document I've put in the red category, then probably I should also put that ambiguous word in the red category. So if I have all the words in my library painted like this, put into different categories, different themes, then I should be able to look for the word field in the context of sports, or field in the context of magnetism, and get some degree of disambiguation. Much better than we had before. Again, none of this is perfect. There's a lot more research to be done, but it's an improvement. And I could also do things like, if I had all these words colored in like that, then I could count up all of the blue words, make a list of all my distinct words, and create these little word frequency tables. So for example, the blue category, it's got a very large number of the word company, slightly less CEO, slightly less earnings. And I can represent that category by looking at those most frequently occurring words. All right, so you might be wondering, who is going to do this word labeling? There's no way anyone can do it by hand. we have to resort to approximate inference and statistical machine learning. And I gave a talk in computer science yesterday where I made my best effort to explain how we do it. I'm going to spare you that. Suffice it to say that we can do this. We can take large numbers of texts that are just documents with no labels whatsoever and give you a representation that's something like this. So we've put each word into one of some number of different categories. We don't know what the categories are beforehand. We only know what the most frequent words in those categories are. We don't know what the labels of the documents are beforehand. We just get the documents. And that's the key to scalability. Good. And so this is what brings me to the library scale topic models. So I have a collection of 1.2 million OCR outputs from pre-1922 out of copyright books. Please don't sue me. They're all okay. If I remove the non-interesting words and the low-frequency words, where non-interesting means the, and, of, that sort of thing, there's still about 33 billion unique tokens. The vocabulary size is about 65,000. And I can get an output that looks like the thing on the right. The way to read this is each row is the most frequent words in a theme or topic. So what you see is that first theme, the most frequent word is killed, second most frequent wounded, then sword, slain, arms, military. And you can see that the contents of this collection are fairly well summarized by this. So there's themes about war, there's themes about philosophy, there's a lot of medicine. There's sea travel, sister, child, tears, pleasure, daughter, loves. And there's sort of family words, being happy and sad. And this is a machine-driven representation of the contents of these 1.2 million books. So we also have all the catalog records, but this is a different way of looking at the contents. All right, so that's the method as a whole. That's what we can do in the computer science department. The question for a humanist is, what can they use that method for? So how can they incorporate it into their research methodology? How can they do the things that they want to do, find out what happened during a particular historical period in ways that are as objective as possible and take into account as much information as possible. So I'm going to show you a case study on a subset of the open source, or the open book collection. These are 19th century novels. We've narrowed the focus down from those 1.2 million books to 3,346 novels. These are by British, Irish, and American authors. There are male authors, females, and unknown authors. There's been a fair amount of work done on identifying author gender. So we know that George Eliot is female, for example. There's a slightly more male authors, and there's a smaller but significant collection of authors for which we really do not know their gender. The texts, if you model books as a whole, you get kind of washed out results. So we break the books into 1,000-word chunks. And we also removed, this was after a lot of trial and error, we found that the method worked best when we removed all words except nouns that were not personal names. Because if you have a novel and you're looking for words that co-occur together, which is what this method really is, you get character names. And the title disambiguates character names. We don't need that. So we had some questions. The first is, do the discovered themes and topics even make any sense for this collection? Previously, topic models have mostly been applied to scientific articles, news articles, that kind of thing, where they're really about something and they're specific technical vocabulary. So the question is, could we even do this on novels? Would it make sense? Second, we wanted to take an external variable, or external to the text, like the author gender, and say, can we find relationships between that external variable, maybe it's gender, maybe it's nationality, maybe it's year of publication, and the choice of themes in a novel. And finally, we were really interested in what we could say about the anonymous authors. So one theory that most people think of first is that, oh, they're all women. Because of the society they lived in, they were not able to publish under their own names. Another possibility, another possibility is that there is no difference. They're just randomly people who don't want to publish under their names. Another possibility is that they are people who are writing about things that they do not feel comfortable about and are deliberately withholding their names, not because of who they are, but because of what they're writing. So that's a hypothesis that we want to test. And finally, and this is the real story of this talk, are these results meaningful? Does the fact that we can measure something mean that we've got a result? Or does it just mean that we can apply a function to data? So let's look at some examples. I'm going to read some of these words because I imagine they're a little difficult to read. This is a topic that we've labeled by hand female fashion. But the most frequent words are dress, silk, gown, lace, hair, muslin, ribbon. If you look, you can go quite far down in the word frequency list. So dressing, gown, slipper, millinery, damsel, plumes, Parisian garment. This is a pretty clean topic. Another one, enemies. That's the human-generated label. That's what we looked at this and said, this is a label that we're just going to refer to this. Enemy, cavalry, front, charge, pursuit, general, speed, campaign, rifles, bivouac. Again, this looks fairly solid. And a third one, which we've labeled convents and abbeys, so convent, abbess, monastery, walls, cloister, protection, length, crucifix, difficulty, secrets, austerities, superstition. Again, we're pretty happy with the themes that we're getting out. So that's kind of the first question. We think this is a reasonable method to use on this text collection. But the second question is, can we measure the association between a variable like gender and the choice of which theme to use? And the way we do that, let's make the data set much simpler, and let's say we only have 5 novels. We can make a table like this for a particular topic. Let's take the enemies topic. And the way to read this is that the first book is by a male author, and 20% of the words in that book, our algorithm has assigned to this topic, which we are calling enemies. Second book, author is male. 30% of the words in that book are assigned to the enemies topic. In the bottom one, we don't know the author. 15% of the words are assigned to the topic. 85% are assigned to something else. So these are not supposed to sum to 0. These are distinct volumes, each of which has its own number. And we can take all of the male authors, all the female authors, and all the unknown authors, and get the average of their proportion. So what is the mean percent use of the topic among a certain category of authors? And we can plot that. And so this is the female fashion topic. The left column is female authors. The middle column is male authors, and the right column is unknown authors. So a few things to note. First of all, female authors tend to use this female fashion topic more than male authors. That was not a surprise to us. But it's sort of reassuring in the calibration sense that we expect to get this result for this particular topic, and yes, indeed, we did get it. The second thing to note is that if we think about our hypotheses about who these unknown authors are, if the hypothesis that the authors were not releasing their names because they were female, if that were correct, then we'd expect that unknown dot to be closer to the female dot. But it's not. It's somewhere in the middle. So that's evidence against the hypothesis that all of the unknown authors are female. Okay, let's look at, this is the enemies topic. We see the reverse. Male authors use this much more than female authors. Unknowns are in between. All right, here's the convents and abbeys topic. And here's something that really caught our eye. So female authors use it more than male authors. Unknown authors seem to use it a lot more than either of those. So this is a case where the unknown authors are not a linear combination of the male and female authors. They are doing something else. So we want to know what's going on here. All right, the first question that we have is, are these results meaningful? And here are 3 ways to ask the same question. So does the difference that we measured reflect a real distinction between male and female authors? Or is it just an artifact of a small sample size? So we're calculating numbers. I scaled it so that one was on the bottom and one was on the top. Is that a real distinction? Or is it just that they happen to be one way or another? If there were no real difference, what is the probability that we would see a result that had as big a difference as that? That's basically the same question. Or another way to put it is, we want to distinguish between a pattern and randomness. If we want to do that, we have to understand what randomness looks like. So how do we do that? There's a method that goes back to Fisher in the 30s, but was published in the 50s, so this is not new science. What we're saying with this test, or with this experiment, is we want to know whether there's a relationship between that gender column and the topic proportion column. We're saying that one predicts the other. So in order to know what it would look like if there was no predictive ability, if there was no connection, we can create a random or an alternative universe where we scramble that middle column. So here's an alternate universe where Wilkie Collins is female, Dickens is still male, we don't know who Jane Austen is, George Eliot actually is male, and this unknown author is female. So there's still the same number of male and female authors. We've kept the sample size the same, but we've scrambled the relationship between those 2 columns. We can do the same thing, count up all the female authors, all the male authors, and say, what would that statistic look like? Where would those 3 points be in this alternate universe where there's no connection? And we can do that 1,000 times, because that's just scrambling data. It takes about 2 seconds. And we can plot that same plot that I showed you before for each of those 1,000 replications and compare it to the real data. It looks something like this. So each of the gray dots is a fake universe. The black dots are the same data that you saw before. The side-to-side is just random jitter so that you can actually see all the points. And what you see is that the actual black points that we observed are way outside the range of any of these replications under the assumption that there's no correlation between the 2 columns. So we're very confident that female authors and male authors use this topic at different rates. The unknown authors are sort of within the range that we would expect if there was no real correlation. And if you've heard about p-values, the p-value means how many gray dots are below the black dot, what proportion of them. Look at the enemies topic, similar, but this is a slightly less significant result. You know, it's still definitely not random, but we're closer to the even distribution. All right, convents and abbeys, our result from before holds up. We're excited. The usage is about consistent. It's unusual, but it's kind of consistent with the null hypothesis. Unknown authors are way above. All right, significance part 2. We were pretty happy at this point, but we wanted to try a different test. And the question we were asking before is, does the pattern that we saw look like what we would expect if there was no actual difference between male and female authors? Now what we want to know is, okay, keep all the male and female authors male and female, but how much variability is there within each category? How much does the number that we saw depend on the specific set of data that we saw, or is it the result of the influence of large outliers? So to do this, we do something called Bootstrap Testing. This is also a fairly well-established method. This is our original data. And what we're going to do is keep the middle column exactly the same. So we have the same number of male authors, same number of female authors, same number of unknowns. And we're going to just erase the other columns. And then we're going to create a new fake data set where for every row, we're going to take a random, if the gender is male, we'll take a random male author. So we get Wilkie Collins. And then for the next row, we'd take another random male author. Oh, we got lucky. We also got Wilkie Collins again. So now we have 2 Wilkie Collinses in this data set. We go through. And then we recalculate again. All right. So that's maybe not that interesting for this data set, but what if this was the original data set? So Wilkie Collins is 75%, Dickens is 5%. There's a big gap. If we do our bootstrap test and we happen to get 2 Wilkie Collinses, we'll get a result that's a mean of 75%, which is much bigger than the 40% we got before. If we get lucky and happen to get 2 Dickenses, we'll get 5%, which is much lower than what we got before. So what we should see is if the category is fairly homogeneous, if it doesn't matter who you get within a category, then the points that we get from replication should be fairly tightly clustered around the actual point that we observed. If they're outliers, we should get a big spread. So here's what we get. The female fashion. Again, these results are pretty good at supporting our hypothesis that there's a difference between usage. Females, there's a bit more wiggle than males. Males just don't really use this topic very much, and they're very consistent about that. Compare that to the enemies topic. Here, the females, there's even less variability, but there's a lot more variability among males. So some male authors are writing a lot about conflict and armed conflict. Others are not writing about it at all. And depending on how many of those war books we get, we'll either get a lot of percentage about enemies or not so much. Unknown authors are kind of in the middle. All right. Here's where we started to get a little worried. So this is the convents and abbeys topic. Female authors, very tightly clustered. Male authors, very tightly clustered. Unknown authors all over the place. And so at this point, we went back and looked more carefully at the data and discovered that there were 2 books in the unknown category that had an unusually high concentration of convents and abbeys. And what was worse, one of them wasn't even unknown. It was an abridgment of an Anne Radcliffe novel that had been marketed without her name on it. And so we were hoping that we would come up with a grand, big conclusion about the identity of unknown authors. What we ended up with was maybe more of a cautionary tale. But we think that this type of skeptical approach to quantitative methods is perhaps more exciting than some great new finding about 19th century novels. Because it shows that we can say things with a lot of confidence, but we can also use these methods, use these randomization tests, bootstrap tests, other tests, to check ourselves and keep ourselves from being seduced by these beautiful hypotheses. So kind of to bring this together, measuring the use of themes is a very powerful tool, but it's not enough by itself. We have to check the significance of those results. And have sort of some some more philosophical points here. The one that I really want to point out is that this work was a collaboration between myself in the computer science department and Matt Jockers, who's an English professor. Neither of us could have done this on our own. I don't really know that much about 19th century novels. He doesn't know that much about randomization tests. We both know a lot more now. But it was really a collaboration between specialists. And also, I think that the real goal of digital humanities, to kind of bring this back to the beginning, is invisibility. That we need to make digital methods and methodologies a part of the standard toolkit that everyone has. You don't have to use them, you can do whatever you want, but it's not a thing. It's a tool that everyone should have access to. So just to close with some credits, I really could not have done any of this without the high-performance computing group at Princeton. They were the first people I talked to who I said, I want 4 terabytes, and they said, okay. Also, the Computing Research Association funds me. I couldn't do this without them. And also, the Digital Humanities Initiative at Princeton is a really exciting group, and we're hoping to collaborate a lot with digital humanities at Yale. So thank you very much.
For our speaker David, and then perhaps others can just come up and talk to the speakers before we give them their lunch as a reward for joining us today. So
that's why I do this.
This is why.
Free lunches.
So is there a question for David? Done.
Yeah, great.
David, you wouldn't be able to do this across languages, would you?
Why, yes, Greg. So what Greg's referring to is if you have a collection where you have links between translations or even comparable documents. For example, Wikipedia also often has articles that have links to not a translation of the article, but the same theme. Then you can align models across languages and measure the use of a theme in different literatures in ways that you couldn't before.
Well, thank you all for joining us. Please feel free to come up if you might have a question or two. There, and look forward to more announcements of more discussions about digital humanities throughout the year. Thank you very much.